Alright, so the first video was talking about how to simplify trig expressions. This next video is going to talk about how to prove trig identities, which maybe sounds more difficult, but actually it's going to be easier because, like, whenever I give you this expression for the first one, you didn't know that this left side was equal to the secant of theta. Well, whenever I ask you to prove a trig identity, I'm going to give you both sides of the equation, or not me, but someone's going to give you both sides of the equation, and they're going to ask you to prove the identity. So you have the advantage, you have the advantage of knowing what the left side is supposed to look like at the end. So it's actually easier. Or if you don't buy into that, we could at least say that it's not any more difficult. So, example 3. Prove the following identity. Cosine of theta times the secant of theta. I forgot my c. Minus the cosine of theta is equal to the sine squared theta. Now, looking at that, I would never guess that this simplifies to that, but apparently it does. So let's prove it. I'm very picky about how you prove these things. You have to pick a side and work from that side only. So I always start with the more complex side. I'm going to start with the left-hand side. You need to rewrite the left-hand side in exact form without changing anything. Don't simplify it at all on the first step. And now I'm going to need to make this look like the sine squared. Well, I'm going to distribute. This is a cosine theta times the secant theta minus cosine squared theta. I'm going to write this secant as 1 over cosine. And you can do this in your head. 1 over cosine times the cosine is 1. So that's 1 minus cosine squared theta. Now this is something that you're probably not going to see right now, but you'll be able to see pretty easy later, is that this is in fact the sine squared of theta. The reason is you know sine squared theta plus cosine squared theta is equal to 1. So if you subtract the cosine from both sides, you get 1 minus the cosine squared theta. But for right now, you know it doesn't seem very obvious, but you'll get better at it as you do more. And that's it. My proof is done. I started with the left-hand side. I justified each step along the way until I got the right-hand side. So I've proven it. Okay? Another one, number 4. Let's prove this identity. Let's prove 2 tangent x secant x equals 1 over 1 minus the sine of x minus 1 over 1 plus the sine of x. Now, you got to decide which side to work from. If I work on this side, I can rewrite the tangent and secant in terms of sines and cosine. But it's going to be very difficult to get it to break into 2 different fractions. I think I'd be better served if I were to start with the right side and combine those 2 fractions into a single fraction and hope that it simplifies to that guy. In other words, I'm going to start with the right-hand side. Write it exactly as you see it. No changes on the first step. Let's get a common denominator. You need to multiply this one by 1 plus sign and this one by 1 minus sign. Again, you can you don't have to show every single step. As long as a sensible person can follow it. Over 1 minus sine x, 1 plus sine x. Next step. Now I'm going to distribute this negative. It's going to change those signs, and I'm going to add my like terms. 1 minus 1 is 0. Positive sign minus a negative sign is a sign. That's 2 signs. Over 1 minus sign, 1 plus sign. That's 2 sine x over, let's expand this denominator out. If I expand, that's 1 minus sine squared And hopefully you can remember this kind of like the last problem. 1 minus sine squared is cosine squared. Now we got to look back to the original problem. I want a 2 tangent secant. Well, one of these cosines on the bottom is going to generate the secant, and the tangent is going to be that sine over that other cosine. So I'm going to write this as sine x over cosine x times 1 over cosine x. And the bell rings, kids are coming. Which is 2 tangent x secant x. And there's my proof.